Hi, I'm Daniel Bean, a PhD student in the Geography Department at the University of New Mexico.
Hi, this is Manideep. I'm a graduate student doing my master's in computer science at the University of New Mexico.
This video will outline the motivation for and use of an interactive web app we developed to study water quality at unregulated wells across the Navajo Nation. There are more than 500 abandoned uranium mines on the Navajo Nation. Contaminants from these mines are known to pollute water sources throughout the region. This is compounded by the fact that about 30% of households there lack running water, so water hauling is common. Some of the wells that water users rely on are unregulated, meaning that the associated health risks may be unclear. We have three groups of target users in mind while developing this app: researchers, policymakers, and individual water users, all of whom have a vested interest in understanding the presence and degree of water contamination. The data used in this app are compiled from multiple federal, tribal, and institutional public sources and have been harmonized into a usable format for visualization and analysis. We also relied extensively on open source examples from the web for implementation. If you follow this link, you will be taken to the working web app that looks like this on load. The About Data button in the top right corner opens a modal window that provides clear details about the web app and a link to download the raw data. Click on the X or anywhere outside the modal window to close it. On load, the map frame, which is powered by Leaflet, displays the political boundaries of the Navajo Nation and more than 1,000 wells that are colored by each well's intended use. As you zoom in on the map, the scale bar in the bottom left updates automatically. Clicking on any well trigger a pop-up with details about that well, including laboratory results for 45 analytes that are pertinent to human health. Similarly, if you click on any of the Navajo chapters, a pop-up will display that chapter's name.
In addition to the web map that represents the Navajo Nation's well data, our web application has three major components. Each of these components will help us get a better sense of the water quality of the wells. The three components are the histograms, data table, and the scatter plots. First, let us look at the four histograms. Each of the histograms helps us visualize the distribution of the wells over a particular analyte. As you can see here, the first histogram has the distribution of arsenic, the second of calcium, and so on. The web app has four drop-downs, each of which can be used to select a particular analyte the user is interested in. In a case where the user does not want to use all four histograms, they have a choice to opt for a none option in the dropdown. Data updation is done by clicking on the update plots. The data table is another major component. It has 5 columns, the well ID, and 1 column for each of the selected analyte in the dropdown. The data present in the data table is used to populate the wells that are rendered in the web map. The scatter plots are another component that our web application has. The scatter plots will be helpful in looking for potential relationships between pairs of analytes. The scatter plots change based on the selected analytes in the dropdown. The scatter plots have a brush function which helps us see any relationships between certain groups of pairs with respect to another analytes. There will be scenarios where the user is interested only in specific wells, say wells that have uranium concentration above 200 microgram per liter. The histograms are provided with a brush option, which can be used to select the area of interest. This will result in only the data of the wells present in the filtered area being passed onto the data table, and hence to the map. The feature helps the users to view only the data of the wells of their interest. The web map also has a counter which keeps record of the exact number of wells selected at all times.
We will code and cross-filter functionality between the scatter plot matrix, the map, the histograms, and the data table, so that when you brush, the other features will update accordingly. We will also include a filter function for users to display only certain wells based on intended use here. Finally, We plan to update the drop-down menus so that each analyte may be selected only once. We would like to thank our instructor, Dr. Yang, for her tremendous support. Please feel free to contact us and view our personal websites at the links below.